Hello everyone and welcome. So today I will be helping you with functions. So functions are expressions which can be graphed on a coordinate plane, and those functions can be represented like this, or like this, and some other ways as well. So functions are graphs where for every x value that's given and input it into the function, there will only be one y value that comes out. So, a very common way of how functions are represented is y equals kx plus b. So this k here is the slope, and this b here is the y-intercept. So if it is in this format, then this graph that is yielded after this would be a function, since when it's like this, it would have exactly one y value for every x value that is given. So another common way that functions are represented is y equals a coefficient if given, along with x to the power of a value. So that as well is also a very common way of functions. So sometimes those also have a add or minus a constant value. Also, functions here can also have it in the form of a parabola. So like this, or like any other way. If it was sort of like tilted to the different positions, like to the left or the right, or like any other function like this. And note what I drew here is just two separate ones. It's not the same. So those, if it was the same, then that would be a hyperbola, which is like this. Well, this or this. So it doesn't necessarily have to be the same at the same place. So these hyperbolas, you can see, have values when those two are represented differently. So whenever it has one x value, it has a different y value. So that would not be the right form. All right. So another common way for functions to be represented is when it is y equals a value, and note that when x equals a value, that would not count. And since that when y equals a value can be represented as just a straight horizontal line, and that would fit the criteria perfectly, since these every x value would have only one y value. In contrast, if it was x equals something, that would just be a vertical line like these two, and for every x value given, there is either 0 y values or 1, or more than one y value. And in the one case where it does have y value, that would be infinite y value. So that would be why when x equals something, that it does not count as a function. So let's try some problems for those. Okay, so this first one asks, is 3x squared a function? Or so let's first graph. Well, that's the second one. This first one here is a x plus 4 function. So let's first graph this one, ax plus 4. So this one has a slope of 8, and a y-intercept of 4. So I'll just roughly graph it here. So like this. This over here is 4, which is the y-intercept. This is 12. Let's just say this is 1. So this is another point where it should be, since that is where the first point would be, since the slope is 8. So we can see from this graph that for every x value given, there is one y value, and that does meet the requirements for being a function. So that would make it, yes, a function. Or let's do the next one, which asks, is 3x squared a function? So 3x squared here, we can graph it like this. This is the rough shape of the graph. It isn't necessarily how it looks like. That is just roughly how it is. So this here has one y value for every x value given, so that would make it a function. So yes, the answer would be yes here. Or so let's try the third one. So this one asks, is x to the power 3 a function? So we'll put this here and see how it looks like on a coordinate plane. So x to the power 3 looks like this. And would this be a function? Well, for every y value given, there is, for every x value given, there is only one y value for every point here. So that would make it a function. Or let's do the fourth one, which asks if 4 is a function. So I'm assuming this question asks y equals 4, not x equals 4, since this is much more commonly used. So we'll just graph that here. So I'll put this as 4, and then it will be like this. So this will just be a straight horizontal line, and that does classify as a function, since for every x value here given, that will always have a y value in return when you find the output. So yes, that would also be a function. Or let's try the fifth one, which asks to graph the function 2x plus 5. So graphing functions is very important in finding if it is a function or not, because you'll have a visual representation of it, and therefore you can prove that it is a function or not, rather than just making wild guesses on whether it is or not. Okay, so 2x plus 5 is a slope of 2 and a y-intercept of 5. So a slope of 2, well, first a y-intercept of 5 would make this pass through that point right there, and we'll have a slope of 2, which is 1, 7 here, this case. So this would be our graph. So would that be a function? Well, this does have exactly one output for every input here, since whenever we put in a x value here, we will always get a y value in return. So yes, that would be a function. And yes, this is the graph here. All right, I'll just write. So this was the part of the question. Same with this one. So I'll just put like that. Okay. So this is our last question, which asks to graph the function x to the power of 2, or x squared. Or I'll bring this over here just so we have more room to do this. So first we have the vertex point, which is either the highest or the lowest point of the parabola, which is what x squared is. So x squared, we would have the vertex of 0, 0, since that is the lowest point. So it'll be like this. And this is true, 0, 0 is the lowest point, because even if we had negative inputs, it would still count as positive. So that would still make the output higher than 0, which is what the lowest point is, which is at 0, 0. Or so let's first so in order to graph a parabola, we need 3 total points, and one of them is a vertex, and the 2 others are the points, such as, which I'll do in this case, 1, well, -1 and 1. So we would take those 2 values and then plug it into the function. So -1 plugging into x squared would yield 1, and so would 1 when we plug that in. So we have -1, 1, and 1, 1 as our 2 points that we can have. So -1, 1, and 1 here. So this will be a point. This will also be a point. So we have those passing through those 2 points. Let me. All right. So this would be the function that's passing through. All right. Okay. So yes, this is also a function. All right. So this will be the function right here. All right. So that would end our lesson for today. So thanks for watching. Please subscribe. Thank you. And also, if you have any questions, feel free to post those down in the comment section. Thank you.